Okay, section 2.4 in algebra. Solving equations with variables on both sides. So we just got done with multi-step equations. This one is still going to be multiple steps, but now we have variables on both sides. In the last one, the variables typically were on either the left side or the right side. But here, as you can see, we've got 100x, and it's on the left side of the equation, 75x on the right side. So one of the things we're going to try to do, we're going to try to get all of our variables onto one side. So what I typically recommend is that you take the smaller of the two and you eliminate that one. So we're going to subtract 75x, which on this side is going to get rid of that 75x. That's going to make it disappear. And over here, we're going to subtract 75x. So now we'll come down and we have 3,225 plus 25x, because 100 minus 75 is 25, equals 3,300. Now we're down to a typical two-step equation. So we'll take and subtract 3,225, make sure it's 3225 like up there. And we get 25x equals 75. And then we'll divide by 25. And x is 3. Okay, this one's a little bit shorter. We had some bigger numbers in that last one. So again, if you think you already have the idea, you can pause the video, try it, and that'd be great. But here we've got some variables. We've got 5x and 2x. One's on the left side, one's on the right side. Okay, so I'm going to get rid of the smaller one. I'm going to subtract 2x. And you can subtract 5x. That'll be okay. You'll just end up with a negative number. But I'm going to do that so that I end up with a positive 3x on this side and still a plus 2. Just notice I'm just bringing that 2 straight down. These go away. The equal sign is in there, and the 2x's go away. And then I'm just bringing that 14 straight down. So those other numbers, I'm not dealing with them right away. But now we will subtract 2 from each side. That eliminates the 2 on the left side. We get 3x equals 12. Then we divide by 3. And x equals 4. Looks good. Okay, let's try the next one. Now, you might say, well, which one's the smaller one? A negative number is always further to the left on the number line, so it's actually smaller than a positive number. So I'm going to add 4x in this one. Again, you can always pause the video to try things. So, or 4k, sorry, not 4x. So in adding 4k, I get 11k on this side plus 12 equals negative 10. Now I will subtract 12. $11k is negative 22. I'll divide by 11. And k equals negative 2. All right, this one, going straight into a story problem. We've been doing quite a few of those. I'm going to jump to the end, kind of like I've told you in class. If it says how many web pages would they have to make. So I'm going to define a variable. W is the number of web pages. Now I'm going to go back and read the question to see if we can figure out how to set up an equation. It takes graphic designer 1.5 hours to make a page of a website. So 1.5 hours times a page, W, a web page. Using new software, the designer can complete each page in 1.25 hours. So it could be, so I'm going to set that equal to 1.25 hours for web page design, but it takes an additional 8 hours to learn the software. So how many web pages would they have to do to basically break even and in this problem? Okay, so I'm going to subtract 1.25 web pages from each side, and why? That would be a smaller number, and if you can't see it's smaller, Add a 0 to that one. That one's 1.50. The other one's 1.25. So we get 0.25 web pages equals 8. Then we will divide by 0.25. You can sure take your calculator out to get that done, but that answer should be 32. 8 divided by 0.25 is 32. And that's our break even point. So more than 32 is actually our answer. So they'd have to do 33 technically, because how many would they have to do in order to save time? Because at 32 they actually break even. So our technical answer has to be more than 32. So it has to be 33 if we read that question correctly. All right, next one. Go ahead and pause the video. Try to set this one up on your own. I'm going to jump in now because I'm assuming you're unpausing the video to see if you got it right. And how many months? So M is the number of months. And it's really where it pays for itself. So that would be a break-even point. So this one doesn't have to be more than that. But it says an office manager spent $650 on a new energy-saving copier. The copier will reduce the electric bill from $112 to $88 per month. So they spend $650, and now it's going to cost them $88 per month. But it used to cost them $112 per month. That's really the equation we're looking at, because see, it cost them this, plus it's still going to cost them $88 per month. Now, what we get in doing this equation, we have variables on both sides. We're going to subtract 88m from each side, and we get 650 equals 24m when we subtract those. We divide by 24, and we're going to find out how many months it takes to pay for the copier. That one's not going to go in there evenly. 650 divided by 24 is 27.08 months. So I'll take it. It's going to take to the 28th month. We are going to have to say by the time it's paid for itself, because at the end of 27, it hasn't. At the end of 28, they'll have saved money and it'll have paid for itself. Part C, a hairdresser. I'll go ahead, pause the video, try this one. Make sure you're doing that if you're watching this on your own. But then it says how many haircuts. So H is the number of haircuts. Again, I always kind of jump to the end to see if I can figure out what do I need here. The hairdresser chooses location A, shall pay $1,200 per month in rent. So that's what they're going to pay at location A, and will charge $45 per haircut. Okay, so now here's the thing. She's going to pay rent. Paying rent, she's going to make $45 per haircut, but it's going to cost her $1,200 in rent. That rent is a subtraction. It will come off the money that she makes. If she chooses location B, we want to set these equal, I assume. She's going to charge more, $60 per haircut. She's in an area where people apparently will pay more for a haircut. I've never paid that much for a haircut myself. Maybe some of you have. That's fine. But $60 for a haircut, but she has to pay $1,800 a month. How many would she get the same profit at each location? Okay, so now we've got variables on both sides. I'm going to take the smaller one, 45H. I'm going to subtract that. And the reason I do that, why do I subtract the smaller one? It gets me a positive 15H. If I had subtracted 60H from each side, then on this side I would have a negative 15H. Then I don't have to deal with negative variables, but you can. Just remember now to bring down both of these. I'm going to bring down 1,800, negative 1,800. Over here it's a negative 1,200. Now I will add 1,800 to each side. And I get 600 equals 15H. I'll divide by 15. I think what I get is 40, but we'll find out. 600 divided by 15. 40 haircuts. 40 haircuts, the break-even point. Okay, continuing on, lesson 24b, we're going to add the distributive property, and we're going to get variables on both sides. So just going to add a little bit more. So the first thing we have to do with this one is we have to distribute the 4. 4 times 2y is 8y. 4 times 1 is plus 4. We have to distribute a 2. 2y on this side minus 26. Now we're back to multiple step equations. We got variables on both sides. We got an 8y, we got a 2y on each of those sides. So I'm going to take that, I'm going to subtract the smaller of the 2 just so I maintain a positive 6y. If you want to subtract 8y, you can. You'll get negative 6y, but then you're going to want to get rid of the other number. Now, in case I haven't explained this yet, and I really don't think I have, the next thing, the reason the 6y is over there, so we want to get rid of anything with 6y. So we're going to subtract 4. We've explained it on other videos, just not this one, to remind you. We're trying to get y by itself. That's why we get rid of the 4, not the 26. Then we divide by 6 to further get y by itself. Now y is isolated. It's all by itself on that side of the equation. Always the goal in solving the equation. We get y is negative 5. Okay. Next up, we're going to try this one. 7 times 4 is 28. 7 times negative a is negative 7a. Distribute the other side. Pause the video as needed. Do the next example if you believe you can. Pausing the video and then check it. 3a minus 12. Now, which one's the smaller one? A negative is always smaller than a positive. So I'm going to add 7a. And that way, see, over here, I get a positive 10a. I like dealing with positive numbers. I bring down the negative 12. The a's are gone. I bring down the 28 straight down. Now I add 12. I get 40 equals 10a. Divide by 10. And a equals 4. Okay, over here, there's nothing to distribute. I have 2a plus 3 equals, now I have 1/2. Now you can take your calculator and you can take 1/2, which is 1 divided by 2, and you can hit equal, it's 0.5, and then you can take it times 6. Half of 6 is 3. That's another way you can just look at it. So that's 3. Well, then you have to say to yourself, what's half of 4a? Half of 4a is 2a. Now I will subtract 2a. There's not a smaller one. And when I subtract 2a, what I get here is 3 equals 3. This is the first time it's happened. Now all the variables have disappeared. If all the variables disappear, then you have two possibilities. One of them is to look, are the numbers the same? They are. That is what we call an identity. They're identical. So we have what is known as infinite. It's that thing that looks like a sideways 8, but it's a loop that would never stop. And we have infinite solutions. That means any number we put in there should work. It really doesn't matter. Okay, go ahead and try this 3. Pause the video. I think there are last 3. So I'm going to go through them rather quickly because we're getting a longer video than normal. But here we take 3 times that. We get 12b minus 6 equals negative 6 plus 12b. Okay, looks familiar. I'm going to subtract 12b from each side. The variables all disappear. Does negative 6 equal negative 6? It's what's called an identity. So when we have identical things, we have infinite solutions. Had that one again. Infinite solutions back to back. All right, this one you might be thinking maybe it's infinite solutions. We're going to see. We have 2x plus 7 on this side. Over here we have negative 1 times 3 is negative 3. We have negative 1 times negative 2x is positive 2x. Okay, we're going to subtract 2x. That's going to get rid of the variables on both sides. But now we get 7 on this side and we get a negative 3 on this side. They are not the same. They're not identical. So this one has no solution. So that's different. It's a very similar problem to the last two, but this time the numbers didn't equal each other. All right, this one we have 4x minus 5 equals 4x plus 2. We subtract 4x. Negative 5 equals 2. They're not the same numbers, so this one has no solution. Okay, hope you got the notes done for this one. Hope you're figuring it out. Thanks for watching.